Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide. This is a direct continuation of the last video that I did where we talked about AeroBrake MFD. AeroBrake MFD is complicated enough, or at least the landing process is complicated enough that I feel like it definitely needed a part 2. I felt a little bit rushed there in getting toward the end of the last video, so I don't really feel like I got a chance to cover it in as much detail as I would like. So let's go ahead and talk more about AeroBrake MFD. Now, I'm definitely going to assume that you did watch part 1 of that explanation, so I'm not going to spend the time to go over everything again. That would be totally redundant. But if you didn't see part 1 of the AeroBrake MFD explanation, definitely go back and watch that first, then come back and watch this video. You're definitely going to need to see that one first because I'm going to completely skip over everything that's already been covered. Now let's take a look here. We're using the same scenario. We're docked at the ISS, and we're going to go through again the basic process of getting away from the ISS and getting lined up with Cape Canaveral. So let's start with AeroBrake, or rather, let's start with base sync. And again, we did a whole how-to type of video with base sync, so make sure you've seen that video as well. So we're going to target Cape Canaveral, and again we're going to warp time forward, and again ED over to direct, and we're going to warp time forward until we have a close passage to Cape Canaveral. And I'm going to see if I can get closer than the 550 that we had last time, so we don't have as much cross range. And if I can't beat that, then what we'll do is we'll actually use some main engine thrust in order to get our base alignment set up a little bit better. But let's see, first of all, if just by going around a few more orbits, if we can get a bit closer. So that we got 500 there. Oh, here we go. 23 kilometers. That's beautiful. That's what we want. So just by going around the planet a few more times, we're able to get much closer. So let's go ahead and bring this around to its orbit number 2, like that. And again, just going through our basic procedures here. If we come down to this panel, we can see that external cooling's off. And we just want to make sure that the radiator is deployed. That way, once we undock from the ISS, our coolant temperature here doesn't start increasing. So check, check. Now Control D to undock. Or I guess you can come up here somewhere. I don't know. There's a dock. Here we are, dock release. Click that. But I usually just do the keyboard shortcut. And let's make sure that we have RCS mode set to linear translation, and we do. So let's press 9 a couple times just to speed up our separation from the ISS. A little bit of 8 to push ourselves down relative to the ISS. And just maybe a little bit of 1. Give us some lateral translation. So we've got all 3 directions. We've got back, down, and lateral, pushing ourselves away from the ISS. Okay, so let's switch over to this view now. And again, we don't need the ISS targeted, so we'll go target, no orbit. And we will go target Cape Canaveral, because that's the base we want to land at. And we have more than one orbit to go. Let's set orbit plane. Let's go ahead and warp time forward. And when we are, this is us right now, and when we come all the way back around to where our vessel is right below KSC, then we're going to be 1 orbit away from the time to land. And we know that also because we have, this is still showing that we're not landing on orbit 1, but orbit 2. So we have to go around the planet a full orbit.
2000.
Coming up here, and you can see as this line crosses that line, then we're now on the final orbit. So we're now 1 orbit away from the time to land. And we want to come around to where we're at the halfway point so that we can lower the other side of our orbit. There's something we can do. We don't have to do this since our distance to Cape Canaveral on this next orbit is so close, but what we can do as we cross the line of nodes here, that's this white line, we can bring our distance to KSC down even more. And let's just go ahead and do that. We've already talked about this in in the video on how to use base sync MFD, but we'll just recap quickly because that's all part of the landing procedure. So I can see that in 591 seconds, I'm going to be at this point, and I'm going to require 1.376 seconds using the full power of the main engines when the vessel is in the orbit minus position. And I know that it's minus because it says minus here. If this said plus, then we would need normal plus, but it's minus. So let's get down to the point where we're just about 100 seconds from that point. About there. And let's go orbit minus. Use a little bit of 10x to speed that up. Give the vessel time to settle. And we'll go ahead and we'll stay at 10x until we are about time to do the burn. Now, time to do the burn, again, we balance our burns, so it's going to be half and half. So when the time to the node is less than 1 second, you know, it'd basically be 0.8 or even 0.75 would be time to do the burn if you're going to use the full power of the main engines. And because we don't want to perturb our orbit too much, we won't use the full power. So we'll use maybe 2/3. And so then we'll begin the burn a little bit sooner, maybe around 5 seconds. Let's go ahead and do the burn now. And you can see the distance to the base is coming down. And when it's 0, kill the main engines.
Rotation.
And if you want, it's absolutely unnecessary, but you can use a little bit of translation plus and minus to bring the distance a little bit closer to 0. But you will note that it will never hold exactly at 0. And when you're talking about meters, it doesn't matter if you're 1 meter or 100 meters. It's exactly, you're exactly pointing at the base. Because if you think about the width of the vessel, you know, the XR2 itself is probably, you know, I don't know, 40, 50 meters wide. So with this number, once it gets down to, you know, 200-300 meters, it doesn't matter to get it any lower. It's absolutely pointless. Okay, so but we are now on track to land, pardon my generic phraseology here, but smack dab in the middle of KSC as we come around on our on this orbit. But again, we need to get to the halfway point to lower the other side of our orbit, so let's do that. And we know when we're halfway around because this line here indicates where the base is at. So by simply warping time forward till this line is exactly over here, we know we're halfway around. But to get a little bit more precise than that, even when we get about here, we can come back to real time, go to the retrograde position. Now we can start watching this distance counter. When it stops counting up and then starts counting down, we know we're halfway around. So let's watch this number. And we can also see here we're getting close. 19.15, we're still counting up. Now we're counting down, so we are halfway around. Let's go to retrograde. Bring up orbit MFD, set the projection to the ship, set the distance to PEA APA, and the frame does not matter in this case. Gauge the full power of the main engines and bring the PEA down to 40 kilometers. And as we get close, we'll kill the main engines so we don't overshoot. And a little bit more to bring the PEA down to about 40. And again, it doesn't have to be perfect. If it's 41, 42, if it's 38, that's all fine. Now, as before, we need to warp forward till the altitude is at the entry interface. And before we do that, let me bring up an external MFD. That way we can have the internal view and we can still have a large look at AeroBrake MFD. Since AeroBrake MFD is the star of the show in this case, and we'll press mod a couple times to turn off that additional information, since for the absolute beginner, that additional information probably isn't going to be terribly useful for you. Okay, so we are at 365 kilometers altitude. Let's warp time forward. Get down to the 120, and we're there. And now let's go prograde, just so that we're facing forward. And we can use a little bit of 10x to speed up that process. And now we'll turn prograde off, switch over to the surface view, and we will roll
rotation
till we are wings level with the horizon. And then we're going to do the same thing that we did in the last video, but this time we're going to have better targeting. We're going to have better targeting at KSC since our off-range, cross-range distance this time was basically nothing. In the last video it was 550 kilometers. So this time you'll get to see the difference it makes by having a cross range of basically 0. We're going to be, our green line is going to be passing straight through the base this time. So again, if we're looking at this view, we can tell where we're going to run out of energy because we are here, that's the green line, and this white line that's kind of dancing around is indicating where we're going to end up. Currently,
27 plus.
Currently, with our vessel being near level with the horizon, it's saying that we're going to go all the way around the planet and then end up somewhere over here. And we don't want that. If the base is here, we want to run out of energy here. So we're going to press 2 on the main keyboard. Again, that's not the numeric keypad, but 2 up here to bring up the attitude hold. And again, the standard Delta glider does not have an attitude hold, which makes this process much more difficult. And that's actually why I'm choosing to use the XR2 to show off AeroBrake MFD. Now you can land the standard Delta glider using AeroBrake MFD, but it's just a lot more difficult and you have to use a different method. Instead of coming in wings level with the horizon like I am here and using a steep pitch, you have to actually tilt the vessel 90 degrees and do a bunch of S-turns back and forth, and it's much more advanced than it is to do it this way. Okay, so now that we've got attitude hold up, let's switch over to AOA. Make sure that this says set AOA and not set pitch. And we want a pitch somewhere around the neighborhood of 40 degrees, so we'll start with that. Once that's set, we'll click engage. And watch what happens here with the prediction
online
in AeroBrake MFD. It's saying now we're here, and with a pitch of this amount, we would run out of energy and land basically right on track at KSC. Right now it's showing that we're just a little bit past it, which is fine. And if we needed to do a finer amount of adjustment, we can adjust the AOA using this 0.5 pitch here. You know, take away a little bit more pitch or add in a little bit more pitch. But again, we discussed kind of the problem with this view in the previous video, and that's that this view doesn't tell us where we're going to end up at, you know, sort of north and south. This just tells us, okay, we're going to run out of energy when we're near the base, but we don't really know where we're going to be at. But if we press PG and then PRJ, we have this view here, and you can see this view gives us a much better indicator of whether or not we're going to actually hit the base. So this green line is extending all the way out to the orange box. So based just on this information, we're in good shape. But if we look over here, again, this box is a zoomed in view of this. We can see that according to this view, we're going to run out of energy a little bit before we get to KSC, and we don't really want that. So if we put in a little bit of pitch this way, in other words, we're going to take away some pitch, so instead of 40 degrees, we're going to go down to 39.5. That's going to extend our range.
Fuel 80%.
And again, you can see just how sensitive it is. That's just 0.5 amount of pitch, and we went from here to here. Now, if you can't get it to where it's going to land exactly on KSC, what you want to do is you want to start off by overshooting. In other words, this will say that you're coming in long, but then as you get closer to the base, you can start adding in a bit more AOA, and that'll have you coming in closer to the base, and it'll get more accurate as you get closer to the base. One thing we can also see is that not only are we coming up a tad bit short of KSC if we use a 40-degree pitch, but we're also coming in a bit to the south, and that's actually fine. And it's actually preferred if you don't come in exactly dead center over top the base, because you remember you have to have time to get out in front of the runway and land. But let's just, for the sake of precision, let's kind of show how we can get this line so that it lays over top the middle. And that's going to be done just by banking the vessel. And since we're coming up out of the south, we need to be banking the vessel a bit to the north. So according to our surface HUD here, we can see that banking to the north would be a bit of a left turn. Now currently we're too high. We're still at 70 kilometers, so we're too high to get any appreciable difference just by banking, but we can put in a little bit of bank. either here by clicking this or by using the number 4 or 6 on the numeric keypad. I'll use those. So I'll press the number 4, and you can see it starts to bank the vessel a bit to the left. And as I do that, it's starting to pull this green line, this indicator, this prediction is starting to pull a bit closer to the dead center of Cape Canaveral. If I put in a little bit more bank, go from 5 degrees of bank to 10, now you can see it's predicting that I'm actually going to go a little bit past the base now and end up at the north side. Now again, for the sake of landing, it's actually preferable that you don't necessarily have your indicator landing exactly on the center, because as you come in to the base, let's say the runway is get closer to the mic, let's say the runway is this way, you don't want to come into the base where you're cutting the runway down the center, because then you have to basically go out and turn around and come back into the land. What makes more sense, if the runway is this way, it makes more sense to end up at the base when you're 20 or 30 kilometers out in front of the runway that way, or you're 20, 30 kilometers out beyond the runway that way. So instead of targeting the dead center of the base, we actually would rather target a little bit to the north of the base or a little bit south of the base. That way we have time to come around and land one way or the other. So as far as what that looks like in AeroBrake MFD, let's say that we want to go north. If we wanted to end up north just for a moment, we would put in, at this point, just 15, maybe 20 degrees of bank until this indicator indicates that we are going to end up like out here. That would be sufficiently far north that we would have time to turn around and bank in and come and land on the runway. But you don't want to keep the bank at 20 degrees all the way down, because as you get lower in the atmosphere, you're getting into thicker atmosphere and you're getting more, the vessel's going to just bank more and more, and you would actually, this green indicator would actually end up way up here. So as we get lower in the atmosphere, we need to slowly take away some of that bank. And if we wanted to arrive south of the runway, then we would simply do the opposite. Let's zero out the bank. So zero bank. And now we can put in a little bit more angle of attack, because this has us out here. So instead of 39.5, we'll have 40. You can see that that indicator is now ending over here. Now let's put in a bit of bank in the other direction. So a bit of right bank. And we probably don't need 20 degrees this time. 15 should be sufficient. And we need to increase our angle of attack a little bit. So instead of 40 degrees, we want 39 or 40.5 rather. That might be a bit too much. We might want to go ahead and go back to 40. But here you can see that this has us arriving a bit south of the base, and again, that's what we want if we want to land on a runway. We want to arrive, one side of the airport or the other. I guess if there were winds, which orbiter currently doesn't have any wind models or anything, so it doesn't really matter which way you land, but pick a direction and land that way. So if we were going to come this way, we would be basically landing on runway 33, which would mean that we're arriving south of the airport, and we're going to plan on turning in north and landing on runway 33. If it were going to be the other way around, then we would plan on arriving up here in this box, which would be north of Cape Canaveral, so then we would turn south and land on runway 15. Okay, so that is how we use AeroBrake MFD. That's the basics of how to use it.
Hull temperature.
I have to close the radiator. I forgot to do that at entry interface. And I have the nose cone still open. So this is going to be a disaster.
Warning, hull temperature.
And you'll actually notice too, as I close the radiator and close the nose cone, it has a big impact on this prediction. That's if they get closed in time.
Warning, airframe overheating.
Might actually incinerate the vessel before they get closed.
Warning, airframe overheating.
Okay, it looks like we got everything closed up in time. But again, the checklists are important, and I didn't go through the checklist properly before landing. But that's actually a good point, because you can see
21.
by having the radiator extended and the nose cone open, it had a big impact on our prediction for where we would land on Earth. So now we actually need to increase our angle of attack in order to pull this back some. So instead of 40 degrees, looks like 41 maybe might be what we need, might even be 41.5. But you can see that that's what AeroBrake's useful for. It gives us that exact prediction of where we're going to end up. And
Mach 20.
that's going to be good enough for that. Okay. Now let's take a look also at one other scenario here just in the last 10 minutes. Clicked on the wrong one. So I'm going to have to exit out. I want to show also that this can be used on Mars. So as soon as this starts up, I will exit out and select the correct scenario.
Warning.
AeroBrake works the same way whether you're using it on Earth or Mars, but it can be useful, I think, to see it in use in multiple examples. And in this case, we're going to be using the standard Delta glider, not the XR2, so we're not going to have that very useful attitude hold autopilot. Let me bring up GL Mars. And we would basically start off by doing the same thing if we're going to land on Mars. Let's start off by bringing up base sync MFD. Let's target Olympus. And we can see, let's ED over to direct, and we can see that in 6 orbits we're going to be 182 kilometers out from Olympus, but on our current orbit we're only 216. Let's bring up map MFD. Let's see. And let's target Olympus. One, two, three, four, five, six. So we're basically halfway around right now. It would be what we can do rather than warping time forward, because 216 or 182 is not a big difference. So we'll go to the retrograde position now, and we're just going to set this to 1 orbit so that we're telling it basically that we want to land on the orbit that we're on. And we can see that the base, again, is here. Our current position's here. We're basically halfway around, so we're going to go ahead and do our deorbit burn now. Projection ship, distance PEA APA. And on Mars, we can actually bring the PEA all the way down to 0. It doesn't have to be 40, because the atmosphere of Mars is much thinner, many times thinner than it is on Earth. So once the vessel gets settled into position, like so, we'll go ahead and apply the full power of the main engines, but being careful not to overshoot. And there we are. PEA is basically 0. Again, if it's a few hundred meters above or below the surface, it actually doesn't make any difference. We can do also, well, maybe, what I was going to say is when we get over here to the line of nodes, we could possibly do an adjustment to bring the off-base distance down, but it may be the case that by the time we get over here, in fact, I'm almost certain it will be, that by the time we get over here, we're going to be low enough in the atmosphere that we won't be able to do any kind of base adjustment. So let's go to the prograde position. Turn prograde off. Now let's warp time forward until we are either at 120 kilometers or we're here, whichever comes first. And it looks like, okay, well, it looks like we're still going to be low enough, or we're going to be high enough that we can get away with doing a bit of a base alignment. So let's go ahead and do that. And we can see that it's going to require 14 seconds using the full power of the main engines with orbit plus. And I know that because it's given here. And by the way, if ED is not set to direct, then you don't have the information that you need. So make sure that ED is set to direct. Because you'll notice if it's set to equator, then our line of nodes isn't in the right position relative to what we're trying to accomplish here. And our PLC doesn't give us valid info. So make sure it's set to direct. Half of 14, basically that's 14 is 7. So when TN is 7, we can apply the full power of the main engines to bring our off-base distance basically down to 0. And we can use full power of the main engine since we are using the Delta Glider. We would prefer to do this earlier because notice our altitude's getting down. Need to start the burn. We would prefer to do this earlier because notice that our altitude is getting down, you know, below 100 kilometers. It would be preferable to do your... Pay attention to the distance. So there again, distance is basically 0. Again, you know, 100 meters, 200 meters makes no difference at all because the width of the Delta Glider, or the width of the XR2 alone is, you know, several dozen meters. Okay, so let's go prograde. And what I'll be able to show here in the last couple minutes is just the relative difficulty that you'll have in landing the standard Delta Glider because you can't, because it doesn't have an attitude hold. So let's bring up AeroBrake MFD, target Olympus, and we'll go ahead and go to PG PRJ right away, and we'll press mod a couple times to turn off that additional information. Now we have RCS mode set to roll, or rotation rather, so let's go to surface mode. Let's roll the vessel wings level. And you can see that AeroBrake MFD works exactly the same way as it does on Earth. Currently, we are cutting right down the center of Olympus, and according to this projection, we would pass Olympus and just keep going around. And that's because we need some additional angle of attack. So if we pitch the vessel way up like this, we can find how much angle of attack we need. And we can see in this case, you know, we need something around 50 degrees. But again, the problem you have here is that you can't hold this attitude. As we get down into the atmosphere of Mars, we're going to be constantly fighting the atmosphere to try to hold this attitude. The best we can do is just to press kill rotation and hold it, and even that's not sufficient, especially once you get down into the lower part of the atmosphere. But this is the best you can do with this standard Delta Glider, is just put the vessel into a certain attitude and then hit kill rotate. But you'll notice that, you know, our prediction is slipping, and it's because it's so sensitive. You know, the coming in and landing, the smallest amounts of pitch one way or the other, the smallest changes in attitude change where you're going to end up by huge amounts. So if I turn off kill rotate and just kind of maybe let the vessel pitch down a little bit, you know, now you can see that green indicator is coming into where I want it to be, and I can press kill rotate and so on. And anyway, the point is, you're never going to land accurately trying to do it this way. The only way to land the standard Delta Glider, in my opinion, is you're going to have to roll the vessel basically onto its side 90 degrees. And you'll notice here your predictions, you just have to do these sort of, you don't have to use kill rotate, you have to do these sort of S turns back and forth. So this is what the vessel looks like, and by the way, we should make sure that the gear's up, radiators closed, nose cones closed, retro doors are closed, you know, go through your checklist. But since this vessel doesn't have any kind of attitude hold, the best you can really do is this, roll the vessel over onto its side and change the pitch, or rather change the roll, you know, continuously. And as we get down into the atmosphere, since we're rolled on our side, we're going to end up, the vessel's going to start pulling itself farther and farther to the north, and we're going to end up missing the base. So what we have to do eventually is roll the vessel 180 degrees the other way, so that we can start correcting, you know, for the base. And again, it's a lot more challenging to do this with the standard Delta Glider, and you can clearly see why. If you use the XR2, you can have that wonderful attitude hold. If you use Dan Steff's Delta Glider 4, I believe it also has a attitude hold of some kind. I've actually never flown the Delta Glider 4, so I don't really know anything about it. But the attitude hold is absolutely necessary, if you want to have really nice pinpoint precision landings. It's actually not too difficult to land the standard Delta glider on Mars just by, eyeballing it. I've done it. I've got a few videos on it. If you're interested, you can do a search for those. But I'm going to go ahead and end it here. I think that gives you enough information to understand at least the basic idea of what AeroBrake MFD is doing and how it works and how you can use it. Again, it's just a prediction system that lets you know when you're going to run out of energy, where you will end up at on the given body. And you just have to do various adjustments with your vessel to make sure that that line ends where you want it to end. And in the XR2, that's much easier, but you can also accomplish the same thing in the standard Delta glider. It just requires a lot more, hands-on piloting, and you have to do a lot of this back and forth type of flying where you adjust the vessel one way and then turn around and adjust it the other way. So I'll go ahead and leave it at that. I hope that that's a good enough explanation of AeroBrake MFD between part 1 and part 2 to give you, again, just the basic idea of how to use the MFD. If you like this video, please leave some kind of comment down below. Let me know what you think. Let me know what your questions are. Subscribe to the channel if you're not already subscribed. That way you can be notified when I upload new orbiter videos. And I also have a Facebook page, and I do recommend that if you're interested in this stuff, that you go ahead and check out my Facebook page as well. You can like it, and you'll be your different things that I post on there will show up in your newsfeed on Facebook. You get to see things on Facebook that you don't get to see on my YouTube channel because YouTube's just strictly uploading videos. But on my Facebook page, I can also share articles, pictures, and other space-related content. Again, just things that you don't get to see here on the YouTube channel. So be sure to check that out as well. Link is in the description, and I will see you in the next video. Not landing on orbit 1, but orbit 2, so we have to go around the planet a full orbit.
2000.
Coming up here, and you can see as this line crosses that line, then we're now on the final orbit. So we're now one orbit away from the time to land. And we want to come around to where we're at the halfway point so that we can lower the other side of our orbit. There's something we can do. We don't have to do this since our distance to Cape Canaveral on this next orbit is so close, but what we can do is we cross the line of nodes here, that's this white line, we can bring our distance to KSC down even more. And let's just go ahead and do that. We've already talked about this in the video on how to use base sync MFD, but we'll just recap quickly because that's all part of the landing. Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide. This is a direct continuation of the last video that I did where we talked about AeroBrake MFD. AeroBrake MFD is complicated enough, or at least the landing process is complicated enough that I feel like it definitely needed a part 2. I felt a little bit rushed there at getting toward the end of the last video, so I don't really feel like I got a chance to cover it in as much detail as I would like. So let's go ahead and talk more about AeroBrake MFD. Now, I'm definitely going to assume that you did watch part 1 of that explanation, so I'm not going to spend the time to go over everything again. That would be totally redundant. But if you didn't see part 1 of the AeroBrake MFD explanation, definitely go back and watch that first, then come back and watch this video. You're definitely going to need to see that one first because I'm going to completely skip over everything that's already been covered. Now, let's take a look here. We're using the same scenario. We're docked at the ISS. And we're going to go through, again, the basic process of getting away from the ISS and getting lined up with Cape Canaveral. So let's start with AeroBrake, or rather, let's start with base sync. And again, we did a whole how-to type of video with base sync, so make sure you've seen that video as well. So we're going to target Cape Canaveral. And again, we're going to warp time forward. And again, ED over to direct. And we're going to warp time forward until we have a close passage to Cape Canaveral. And I'm going to see if I can get closer than the 550 that we had last time, so we don't have as much cross range. And if I can't beat that, then what we'll do is we'll actually use some main engine thrust in order to get our base alignment set up. Press 9 a couple times just to speed up our separation from the ISS. A little bit of 8 to push ourselves down relative to the ISS. And just maybe a little bit of 1. Give us some lateral translation. So we've got all three directions. We've got back, down, and lateral, pushing ourselves away from the ISS. Okay, so let's switch over to this view now. And again, we don't need the ISS targeted, so we'll go target, no orbit. And we will go target Cape Canaveral, because that's the base we want to land at. And we have more than one orbit to go. Let's set orbit plane. Let's go ahead and warp time forward. And when we are, this is us right now, and when we come all the way back around to where our vessel is right below KSC, then we're going to be one orbit away from the time to land. And we know that also because we have, this is still showing that we're not orbiting, we're a little bit better. But let's see, first of all, if just by going around a few more orbits, if we can get a bit closer. So that we got 500 there. Oh, here we go. 23 kilometers. That's beautiful. That's what we want. So just by going around the planet a few more times, we're able to get much closer. So let's go ahead and bring this around to its orbit number 2, like that. And again, just going through our basic procedures here. If we come down to this panel, we can see that external cooling's off. And we just want to make sure that the radiator is deployed. That way, once we undock from the ISS, our coolant temperature here doesn't start increasing. So check, check. Now Control D to undock, or I guess you can come up here somewhere. I don't know. There's a dock. Ah, here we are, dock release. Click that. But I usually just do the keyboard shortcut. And let's make sure that we have RCS mode set to linear translation, and we do. So let's